All right, so second part of quadratics, all right? Last time, we basically just learned how to tell what A, B, and C were, and if it was up or down, and then also how to find the vertex. This is a little continuation on that, where we're going to learn about the axis of symmetry, and we're also going to learn about maxes and mins, which are important when you graph, all right? Just a quick little review. I'm going to start off with this equation right here and state whether the graph will open up or down, and then we're going to find the vertex, okay? So exactly how we did last time. First, I'm going to go through A, B, and C. So whatever is in front of x squared is A, whatever is in front of the x is B, and the plain number with no x will be C, okay? So positive 2 is the number in front of x squared, so that is A. The number in front of the normal x is negative 8. Remember to keep the sign with it, so B is negative 8. C, the leftover number at the end is 5, okay? So remember, the graph will open up or down depending on if A is positive or negative, all right? When it's positive, the graph will open up. It'll be a happy graph, okay? It'll look something like this. If A was negative, it would open down. The last thing it wants us to do is to find the vertex of the graph. So remember, to find the vertex, we would use the equation x equals negative b over 2a. This would give us the x-coordinate, the first half of our vertex. So first thing you do is you plug in b and a into this equation, all right? So x equals negative b. B is negative 8, so negative b would be positive 8. Negative and negative equal positive. Over 2 times whatever a is. In this case, it's a 2. So 8 over 2 times 2, which is just 8 over 4. 8 divided by 4 is 2. So the first part of our vertex is 2. Now what you do is you plug 2 into everywhere you see an x in the original equation. So our original equation was y equals 2x squared minus 8x plus 5. So anytime I see an x now, I'm just going to plug a 2 in for it. So y equals 2 times 2 squared minus 8 times 2, and then plus 5 at the end. 2 squared is 4, so 2 times 4. Negative 8 times 2 is negative 16, and then 5 at the end. 2 times 4 is 8, minus 16 plus 5. And then from here, it's pretty straightforward. You can just use a calculator. 8 minus 16 is negative 8, plus 5 will be negative 3. So our vertex, we got x equals 2 and y equals negative 3. So the coordinate of our vertex is 2, 3. Right? That's what we learned last time, basically all in one problem. Now we're going to learn about something called the axis of symmetry. So symmetry is exactly what it sounds like, right? When something is symmetric, it means that something on one side is the same as something on the other side, kind of like a mirror. So if you notice this parabola, parabolas are symmetric. If I would cut this in half, it would look the same on this half as it does in that half. So the axis of symmetry is just wherever that cut is going to happen, which makes it symmetric, okay? So where do we cut the graph in order to make it the same on both sides? Well, we want to cut it at the vertex, the middle, right? If we cut it in the middle, it'll look the same on each side. So if we made a cut on the vertex like this, it would cut this parabola in half. It's the exact same on this side as it would be on this side. Okay, wherever you cut, that is called the axis of symmetry. So you might notice the vertex of this graph was 1, negative 4. That was the vertex, okay? The x-coordinate is your axis of symmetry. So x equals 1 is the axis of symmetry in this case. So basically all you have to do to find the axis of symmetry is you find the vertex of the graph, and then whatever the x-coordinate is, that is your axis of symmetry. And you always need to make sure that you write x equals. You can't just write 1, because 1 is just a number, it doesn't tell me anything. You have to say x equals 1, and that is the axis of symmetry. Okay, so step 1 would just be find vertex. Step 2 is use the x coordinate, and then you'd be done. All right, so what we're going to do, we're going to do 2 examples where we work through equations finding the axis of symmetry, and then we're going to work through 2 examples where we just look at the graph and find the axis of symmetry that way. Okay, so remember, step 1 was basically we want to find the vertex, or we could be smart and just find the x portion of the vertex, because I only care about this coordinate. I only care about the x. I don't care about the y, so I don't need to find it. So in this first equation, I am going to start off using the vertex formula. So x equals negative b over 2a. And actually, when I find this vertex, when I finish this, I'll be done, because it's going to give me the x coordinate. So all you have to do for this type is just do the vertex formula and you're done. So plug in b and a. So looking at the original equation, a is 3, b is negative 12, c is 6. Remember, you're just looking at your numbers. So I'm going to plug in negative 12 for b. Since this is a negative b and 12 is negative, they cancel out and make a positive 12. A is 3, so 2 times 3. Basically, this will be 12 over 6. So x equals 2. And you're done. That is your axis of symmetry for this particular equation. X equals 2. You don't have to go through and plug 2 back into the equation, because that will give you your y. I don't care about y right now. I just care about my x. So here you're done. Second example, you're going to do the same thing. Write out your a, b, and c, because you're going to need those for the vertex formula. A is negative 2. Remember, it's whatever's in front of x squared. B is whatever's in front of x. So in this case, it's an 8. C is negative 9. So plug into your equation b, so you get negative 8 on top, then plug a into the bottom, 2 times negative 2. Negative 8 over negative 4. 8 divided by 4 is 2, and since we have 2 negatives, those will also cancel out. The negatives will cancel. So here, x will equal 2 once again. So that is my axis of symmetry. The graphs are pretty easy. Just look for that vertex point right in the middle. So in this case, my vertex is 2, negative 1. And remember, you only care about the x coordinate. So axis of symmetry here is x equals 2. And it makes sense because if I draw a line right down the middle, that would cut it in half. And that is at x equals 2. Number 4, last example for these questions. Find the vertex. It's right there. The coordinate of the vertex is 3, 1. The x coordinate is a 3. So the axis of symmetry is x equals 3. All right. That is axis of symmetry. The last thing we are going to go over today is max and min values. All right. You might remember these from Algebra 1. Basically, the maximum is the biggest y value in the graph, the highest point. The minimum is the lowest y value in the graph, or the lowest point, okay? So we are working with parabolas, these U-shapes. All right, so each graph will either have a max or a min. It can't have both, okay? For example, an up graph, a happy graph, has a minimum point because it has a lowest y value, but it doesn't have a max because these points go on forever. They go up to infinity, and infinity is not a number, so it doesn't have a max. So up graphs have a min. They will always have a min. They'll never have a max. The down graphs, the sad graphs, will always have a maximum point at the very top. Okay? So down graphs have a maximum. Okay? It's one or the other. If it's up, it has a min. If it's down, it has a max. All right? 3 more examples that we'll work through, and then we'll finish there. Okay, so quick thing to note, the max or min will always be the y-coordinate of the vertex. Okay, if you notice from the last page right here, what we just did, whether it was an up graph or a down graph, the max or min was always at the vertex, right? The vertex will always be the max or the min. So just like when you were finding the axis of symmetry, now you only have to pay attention to the y-coordinate. With the symmetry, you had to pay attention to the x. With max or min, you have to pay attention to the y. Okay. So in these examples, what it wants us to do is find the max or the min given the equations. Here are the steps. First, we find if the graph opens up or down. If it's down, it's a max. If it's up, it's a min. We find the vertex of the graph. And then whatever the y-coordinate of that vertex is our answer. Okay, so first, does this graph open up or down? So x squared minus 2x minus 2. Remember, the way you tell if it opens up or down is if a is positive or negative. Okay, if a is a positive number, it opens up. If a is a negative number, it opens down. So a here is positive 1. You look at the number in front of x squared, it's invisible 1. So this is an up graph. Let's see, it says that up graphs give you a minimum. So this point will be a min. Now I'm going to go through my vertex equation and follow it all the way through. So x equals negative b over 2a. Okay. B in this equation is negative 2. So x equals 2 over 2 times 1, because a is 1. This is 2 over 2, or 1. So in this case, our x-coordinate would be 1. But that's our axis of symmetry. I want our minimum. So now what you have to do is you have to go and plug 1 into everywhere you see an x in the equation. So you have to go all the way through the vertex process. So y equals 1 squared, just plugging a 1 into everywhere there's an x, minus 2 times 1, minus 2. Y equals 1 squared is 1, negative 2 times 1 is negative 2, into minus 2. So for y, 1 minus 2 is negative 1, minus 2 is negative 3. So the minimum point on our graph is y equals negative 3. That is our min. That's the lowest point on the graph. So you had to have your parabola, this would be your min, and it would be y equals negative 3. But all you have to put is this y equals negative 3. Okay, so that's the basic process. Does the graph open up or down? Find the vertex, state the y-coordinate. All right, one more time, or 2 more times, excuse me. For example number 2, I have to find a to decide if the graph opens up or down. A in this case is negative 2. It's negative, so this graph opens down, which means it will have a max. Now, find the vertex. X equals negative b over 2a. B is negative 16, so negative b is positive 16, and then 2 times a is negative 2. So this is 16 over negative 4. Whoops, negative 4. Negative 4. So 16 divided by negative 4 is negative 4. You can use your calculator to check your work, but our x is negative 4. Plug this x into everywhere you see an x in the original equation. So y equals negative 2 times negative 4 squared minus 16 times negative 4 minus 36. Some of our numbers will get pretty big here, so we'll need to use a calculator. Y equals negative 2 times negative 4 squared is positive 16. Negative 16 times 4. Okay. This is going to be 64. Let me check that real quick. Yep. 64 positive. Negative times negative is positive. So this will be a plus 64, then minus 36 at the end. Negative 2 times 16 is negative 32, plus 64, minus 36. Negative 32 plus 64 is 32, minus 36. And we get y equals negative 4. So this is the maximum of our graph, the highest point that would be on that graph. All right, last one, and then we're done. First, find a to decide if it opens up or down. A equals 2, so this is an up graph, which means it has a min. Work through your vertex formula. B in this equation is negative 8, so positive 8. A is 2, so 8 over 2 over 2. 8 over 2 times 2, excuse me. That's 8 divided by 4, or 2. So x equals 2. I'm going to plug 2 anywhere I see an x in the original equation. So 2 times 2 squared minus 8 times 2 plus 5. So 2 times 4 minus 16 plus 5. 8 minus 16 plus 5. Negative 8 plus 5. So y equals negative 3 at the very end. And that would be your minimum point for number 3. Okay? Again, these notes should be on Classroom. If they're not, just email me. Also, email me with any questions. If you feel like you need to talk with me face-to-face or you need me to help you work through a problem, kind of in person, email me and we can set up a Google Meet. Besides that, that is it for the second part of quadratics.